My name is Haina, and this is my presentation on the effect of lead-acid battery recycling on Haina, Dominican Republic. The purpose of this presentation is to review the health implications of lead poisoning, discuss the exposure of lead at the residents of Haina face, examine the value of proper waste removal, as well as recap the events that occurred at the site since the initial exposure. We'll be going over a location overview, history of the health issue, measures of lead exposure, as well as the lack of site intervention, and finally the results of effective site remediation. Here's an idea of where Haina is in the Dominican Republic. It's just about 10 miles southwest of Santo Domingo, which is the capital of the Dominican Republic. Our story begins with a used lead-acid battery recycling plant in operation until 1997. In March of 1997, researchers conducted a survey with 116 children that lived in the community near the recycling plant. Testing for blood lead levels in these children revealed that a significant amount of lead was present in their blood, and as a result, the government shut down the plant and site in 1997. Before we go any further, let's review why lead exposure is so bad for human beings. First off, it causes brain and nervous system damage, slow growth and development, as well as learning and behavioral problems. Of the groups most affected, children under 6 years old are typically the most affected. There is no determined minimum safe level exposure by the CDC. However, they picked 3.5 micrograms per deciliter of lead in blood as a mark, as 98% of children have under that mark of lead in their blood. Most commonly, lead is exposed to human beings through inhaling or swallowing lead dust, and it's measured through blood lead levels as well as erythrocyte protoporphyrin as well as zinc protoporphyrin levels in the blood. However, for this presentation, we'll be focusing on blood lead levels. Here's a figure showing the frequency distribution of blood lead levels amongst children in Haina in August of 1997. Looking at this graph, notice that only 9% of the children are under 10 micrograms per deciliter lead in their blood. That's considered an okay level or an okay threshold back in 1997 for lead exposure, but the other 91% of children are way over that amount, and some of them even over 10 times that amount, with 1% of children above that mark. The next figure is also a frequency distribution of blood lead levels, but this time in the neighboring town of Parsiculo. It was chosen due to its proximity to the town of Haina being right next to it, as well as the residents having similar socioeconomic status. As you can see here, the children here are exposed to a lot less lead, with 42% of the children containing less than 10 micrograms per deciliter of lead in their blood, compared to only 9% of the children in Haina. This is a frequency distribution of blood lead levels in Haina from March of 1997, which was right before the battery recycling plant was shut down, to August of 1997, which was about 6 months after the recycling plant was shut down. As you can see, there are a lot more children with a lot less blood lead levels in the distribution, with a big shift heading towards the left. The next figure switch is showing mean blood lead levels over time, and we can see on the left-hand side the sharp decrease from about 71 average blood level in 1997 before the factory shut down to just about over 30 after a shutdown in August. However, after another blood sample was taken around 2007, the blood levels have remained largely the same over a 10-year time span. Adding this line shows the lower blood lead level of exposure at around 10 micrograms per deciliter back in 1997. This next line shows the current CDC recommendation, which is to get tested once your child is about over 3.5 micrograms per deciliter, that same number I mentioned earlier. And as you can see, children in Haina at this point in time were still about 10 times more than the current CDC recommendation, and still 3 times over the 1997 safe level. So why aren't lead levels decreasing? Even though the recycling plant was shut down in 1997, the lead waste that was present at the recycling plant was never properly removed. Initial attempts at containment with concrete blocks had failed after a few years. Lead waste continue to persist at the site, mixing in with the soil and persisting in the environment, as well as mixing in with the water supply, which help further increase the amount of contamination. However, if we extend the last line graph to 2014, we can see indicated by the yellow line a sharp decrease in the amount of average blood lead level over time. And the reason for that is due to site remediation beginning in around 2008-2009. So what happened in 2009? The Blacksmith Institute, now known as Pure Earth, along with Terragraphics Environmental Engineering, assisted in site remediation. High-level waste was transported to a new facility that met strict regulatory standards. Soil that was highly contaminated with lead was taken off-site, with about 6,000 cubic meters in late 2008, early 2009, and 4,000 cubic meters in 2010 removed, for a total of 10,000 cubic meters. The remaining waste was properly entombed at the site with concrete. Walls were constructed also at the site to prevent soil erosion and prevent contamination in the water supply. Children were also educated in an attempt to minimize further exposure to lead dust and materials, and the site is currently now the location of a park. In summary, lead acid batteries are being recycled in Haina, Dominican Republic, with waste not being properly disposed of. This led to a severe exposure of lead to the residents there. While the recycling plant ceased operations in 1997, harmful levels of lead remained in the area. From 2008 to 2010, site remediation efforts to remove the lead waste resulted in significant drops in blood lead levels. Now, currently, the blood lead levels are at an acceptable rate for residents, and now the former recycling facility has been turned into a public park. Thank you for watching. This concludes my presentation.